confirm பண்ணிக்கோங்க ஏன்னா I have started sharing. So last class we have finished current electricity, so different topics cover பண்ணோம், and அது related நம்ம numericals பார்த்திருந்தோம். Competitive questions we have covered for current electricity. So I hope current electricity is clear. So if at all any doubts also, you can get back to the video lectures and you can definitely see. And you can personal questions WhatsApp பண்ணலாம். So definitely, when I'm free, I'll definitely revert back with an answer. Okay, so we will move on now with the next chapter, which is magnetic effects of current. So magnetism kulla ipo enter panna porom. So as usual, I'll first brief up the concepts before we move into the questions. So concepts ஒரு வாட்டி பார்த்துடலாம். We look at the concepts and then we will eventually start with the numericals. Say, where do we go? Yeah, I think now the annotating tool is working. So we will start off. Yes, it's charged fully. So we are starting with a chapter called Moving Charges and Magnetism. So we look at each and every concept now in detail. This chapter, Moving Charges and Magnetism. So adu paakalam. Yeah, here we go. So first concept, properties of charges வந்து உங்களுக்கு தெரிஞ்சிருந்தா நம்ம ஏற்கனவே பார்த்துட்டோம். So with respect to the different observations by Oersted, so அதை நம்ம பார்க்கலாம். Observations by Oersted. So first part, so usually Henry Oersted அப்படின்னு சொல்லுவோம், இல்லைன்னா Oersted Henryன்னு சொல்லுவோம். So he was a physicist who gave the idea about the relation between magnetism and electricity chapter. So electricity and magnetism both are correlated அப்படிங்கிற ஒரு கான்செப்ட் வந்து இவர் தான் கொண்டு வந்தாரு. So how he basically found out the link between electricity and magnetism is quite interesting, and it was purely accidental. ஸோ இப்போ பார்த்தீங்கன்னா நம்ம கிட்ட இருக்கக்கூடிய எல்லா லாஸுமே வந்து சிலது எல்லாமே வந்து இட் வாஸ் நாட் ஃபவுண்ட் அவுட் இன்டென்ஷனலி. Especially Newton's law பாத்தீங்கன்னா it is accidentally only found out. Newton did not want to find Newton's law in the first place. By visualizing real life situations, அவருக்கு நடந்த சில இன்சிடென்ட்ஸ் தான் அந்த law வந்து find out பண்றதுக்கு it was very useful. So everything was purely situational, it was purely accidental. The same way இங்க the observation of magnetic field, the relation between magnetic field and electricity, இதோ கூட பாத்தீங்கன்னா ஹென்ரி ஆய்ஸ்டட் இல்லைன்னா ஆய்ஸ்டட் ஹென்ரி அப்படிங்கிறவர் வந்து ஆக்சிடென்டலா he just carried a compass, ஒரு மேக்னெட்டிக் காம்பஸை வந்து ஒரு சர்க்கியூட் கிட்ட கொண்டு போனாரு. ஸோ கொண்டு போகும்போது he saw that magnetic needle வந்து டிஃப்ளெக்ஷன் காட்டுச்சு, it started moving. So that is what made him think, என்னடா இது ரிலேஷன் இருக்கும், what is the relation between electricity and magnetism, So that is what brought life into a new chapter, into a new branch in physics called electromagnetism. So electricityயும் magnetismமும் ரெண்டுமே it goes hand in hand அப்படிங்கிறது வந்து he was the first person to basically identify it, and then later on discoveries were made, research and development was done, and we have new concepts to this new field in the branch of physics. ஸோ அதுதான் எலக்ட்ரிசிட்டி அண்ட் மேக்னட்டிசமோட கோரிலேஷனு. ஸோ இதை வந்து நம்ம எலக்ட்ரோமேக்னட்டிசம் அப்படின்னு சொல்லுவோம் இந்த branch. So that is what we are going to deal with today. So we will be looking at what is the magnetic effect of current. So ஒரு current flow பண்ணும்போது ஒரு conductorல, when current is flowing in a conductor, we wish to understand what is the magnetic effect involved with it, and how, what are the different repercussions and how it is basically involved அப்படிங்கிறத நம்ம பார்க்க போறோம். In stages we are going to see today. So first one, observation by Oyster. Very simple. What he observed is, I'll just put it in words, in simple words. He observed that a compass needle, compass அப்படிங்கிறது நம்ம எல்லாருக்குமே தெரிஞ்ச ஒரு instrument தான். We are quite familiar with this. It is not Greek and Latin to us. So compass needle is something which gives us the geographic directions. So north south direction வந்து குறிக்கும். So at any point in time, if you take a compass and you just keep it in the horizontal position, you can see that the deflection would stop at a point and the needle would point out the geographical north and the geographical south, okay, of the earth. So you can see the directions. So in the direction at a time, one direction you can accurately measure using the compass. Okay, so a compass needle suffers deflection when it is placed when it is placed near a wire carrying current. So this is the main observation by Oyster. So when he placed a compass needle next to a current carrying conductor, what did he observe? He observed that there is a deflection. It started moving. So that's what made him wonder what is the relation between electricity and magnetism. Okay, so adhe mari, when the current direction is reversed, when the current direction is reversed, the deflection of magnetic needle also reverses. So this is the observation that Oyster basically saw. So these were the observations that he made. Based on these observations, he was able to prove the fact that current carrying conductor produces magnetic field. So what was his conclusion? Adum paathulla. So finally, Henry Oyster was able to conclude that a current carrying conductor produces magnetic field around it. Okay, so that is what he was able to conclude at the end of the day. Cheringla. So this is the observation. We have seen the observation by Oyster. Same way, based on his observation, what is the conclusion that he drew? So in the rendume nama vandi we have seen this is the first part of this chapter, quite important. Okay, even though it's a theoretical aspect, just you need to have an idea of how things were basically identified in the first place. Second one, it's the most important law. Idu neenga already padichirpeenga, Biot-Savart law. So we are going to see what is this Biot-Savart law. Okay, now romba simple da. Perusa idhula vanda there is nothing to be complicated. I'll just put it on simple terms. So according to this law, the magnetic field, I'll just first write it down. The magnetic field due to a current carrying due to a current carrying small element due to a current carrying small element dl அதை வந்து ஒரு வெக்டர் நோட்டேஷன் கொடுப்போம் small element dl because we use a displacement vector small element dl carrying current I again I am using the notation capital I carrying current I at a point P okay at a point P located at a distance R is given by so இங்க வந்து we are taking current carrying element so imagine this is a current carrying conductor ஒரு இது ஒரு wire வந்து நம்ம கன்சிடர் பண்ணிருக்கோம் this is the current carrying wire it's not straight it is a random wire that we have chosen okay just for generalizing so in this current carrying wire I am choosing a very small portion so when I'm saying current is flowing through it I need to represent using an arrow mark so I will say this is the direction of current and I'm showing the symbol of current so that is what we do intuitively okay you show the direction of current and I have taken a small element this small element is called as dl இதுதான் நம்ம dl அப்படினு சொல்றோம் very small elements very small length we are taking so when you choose a small length what you are doing with that with respect to that point we are drawing a tangent so anga we are basically drawing a tangent at this point so on the dl point oda center வந்து நான் மார்க் பண்ணிருக்கேன் and let's draw a tangent to it okay so I'm using a dotted line notation so just draw a tangent to that point now we are finding what is the magnetic field at a point P so இதுதான் point P now this point P is located at a distance of R so in the distance பாத்தீங்கன்னா is purely R okay so this point we will take it as O so OP is equal to R so that is the distance so the magnetic field at point P
sir,
yes
sir OP எதை சார் ரெப்ரசன்ட் பண்ணுது
OP வந்து is this length this is OP okay that is again the distance from the point of interest so at point P with respect to a current carrying wire ஒரு சின்ன பகுதி நம்ம எடுத்துக்கோம் dl so the magnetic field at point P due to that small element dl which is carrying again the current I so will also be small அதனால I am representing that using dB so dB is the magnetic field very small magnetic field associated with that small element dl so this is what we try to show here okay this is the basic idea at a distance of R from point O the magnetic field associated at point P is going to be dB because we are choosing only a small element dl suppose nama motta we are basically considering the entire conductor then obviously magnetic field is also going to be big it's not going to be small greater the current greater would be the magnetic field associated so nama inga we are taking only a small element so that's the reason the magnetic field associated with a small element is also small adha nama intuitive nama consider பண்றோம் ஓகேங்களா now as far as this law is concerned this magnetic field dB is directly proportional to the current passing through the conductor this is the first and foremost thing that you should know okay so the magnetic field and the current both are proportional okay so you send more current magnetic field is also going to be more it is also going to proportionately increase that is the first and foremost thing that you will have to know and second one the magnetic field dB is inversely proportional to the square of the distance which is also called as inverse square law so ஏன் நம்ம இங்க இன்வெர்ஸ்லி சொல்றோம் எதுக்கு நம்ம டைரக்ட்லி சொல்லல அப்படினு பாத்தீங்கன்னா as you go away from the conductor, don't you think the magnetic field இல்லனா magnetic effect will get reduced? Obvious sir. Yeah, that is what
Yes,
that is
sir.
what you know. மேக்னெட் நீங்க சிம்பிளா ஒரு பேர் மேக்னெட்டே எடுத்துக்கோங்க. ஒரு பின் வைக்கிறீங்க, ஒரு சேஃப்டி பின்னோ இல்ல அயன் பார்ட்டிகல்ஸோ அது பக்கத்துல கொண்டு போறீங்க, அட்ராக்ட் ஆகுது. சரி, ரொம்ப தூரமா வைக்கிறீங்க, அது அட்ராக்ட் ஆகுமா? It won't attract.
No, sir.
Why it won't attract? Because அது மேக்னெட்டிக் ஃபீல்ட் ரீஜன்லயே இல்ல, அந்த மேக்னெட்டிக் ஃபீல்ட் பகுதியிலேயே அது இல்ல. So when it is not in the region of magnetic field, obviously it's not going to get attracted. For something to be attracted, you should go inside the region of influence. Only if you are within the region of influence will that object be attracted. Otherwise it's not going to be attracted. Same logic applies here also. நம்ம point P வந்து if you are moving away, if you are going to choose a point very far away from this current carrying conductor, the magnetic field associated is going to be literally very very less. அப்படி இல்லைனா you can also say it is going to become zero as you go away. Yes, obviously it is going to become zero. So that is the reason magnetic field is inversely proportional to the square of the distance. So as the distance increases, magnetic field decreases. As the distance decreases, magnetic field will increase. Yes, அதுதான் நம்ம இன்வர்ஸ் ரிலேஷன் சொல்லுவோம். ஒரு குவாண்டிட்டி கம்மியாகும் போது the other quantity will increase. அது அதிகரிக்கும். ஸோ இதுதான் நமக்கு வந்து பேசிக் ஐடியா. Okay, so now we are moving on to the next part. So this is the magnetic field relation with current, magnetic field relation with the distance, with the square of the distance. Okay, next we are also relating magnetic field with, apart from this, what else we have here is the distance, and you have the small element dl. இது ரெண்டுமே இருக்கு. Now it is basically making an angle theta. இப்போ பாத்தீங்கன்னா that point P, அதாவது OP is making an angle theta with the tangent of the wire. So இந்த angle தான் நான் சொல்றேன். So I'll mark it using a different color so that you can identify. In green color use பண்றேன். This angle is theta. So if that angle is theta, we are going to express both of them in terms of their vector cross product. So vector cross product அப்படின்னு பார்த்தீங்கன்னா இங்க what are the different vectors அப்படின்னு பார்த்தீங்கன்னா dl is one vector, displacement vector, and r bar is also one more vector. So two vectors are there. That's also a displacement. The position vector னு சொல்லுவோம் usually physicsல. We have one position vector and you have one displacement vector. So whenever you have two vectors, so we are considering, and you have an angle between them, so therefore we use vector cross product. So inge dB is also proportional to the vector cross product of dl bar and r bar. So that is dl cross r bar. So this is the third one. So இப்போ இந்த மூணுமே நம்ம combine பண்ணுவோம். So if I combine all the three relations, what do I get? Combining equations 1, 2 and 3. So what will I get if I combine all the three? I will get dB is proportional to I times dl cross
I
r.
dl plus r rector divided by r square.
Yes, divided by r square. ஓகேங்களா? இப்போ எனக்கு proportionality and the sign வந்து I want to remove. So if I want to remove the proportionality sign, I should introduce a proportionality constant. That constant is called k. So we will take it as k. So k times I. இப்போ நம்ம cross product வந்து நம்ம expand பண்ண போறோம். What is a bar cross b bar? Can you tell me? Already we would have learnt in grade 11. A bar cross b bar is equal to a vector a times vector b into sin theta.
Sin theta.
Isn't it? So times sin theta. So we are applying that now here. So adhe mari dl bar cross r bar will be dl times r times sin theta. Okay, so we can express it like that upon r square. So we are expressing it like this. Okay, now usually ideal sin theta அப்படின்னு நம்ம express பண்ணுவோம். Okay, so this is how we express. So this is again a relationship that you need to know. One second, nama current is also a vector. So let me just change it. Small error. We will change it. R வந்து நம்ம பொசிஷன் வெக்டர் கன்சிடர் பண்றது இல்ல. ஏன்னா I'll tell you why. Yeah. ஏன்னா that point is fixed. R வந்து is a distance which is fixed. And obviously the direction is known to us because we are choosing the point P with our interest. ஆனா current வந்து I is a vector தான். Current is a vector quantity. You have both direction as well as magnitude in current. So you consider I cross dl, not R. So R வந்து நம்ம வெளியிலேயே வச்சுக்கலாம். Let me just change that. So just now it striked me. So we will change it. So dl bar cross I bar. So இங்க I போட்டுக்கலாம். ஓகேங்களா? So appropriately we will make the change. So here I will take I inside and keep the R outside. Okay. Yeah. So same way. So now what will be the changes here? So appropriately the changes will be
சார் அப்போ ஆறும் ஆறும் கேன்சல் ஆயிடாதா?
ஆமா கீழே ஆர் வந்து கேன்சல் ஆரே நம்ம எடுக்கலையே. ஸோ ஆர் இல்லையே மேலே.
ஓகே சார்.
Okay, so because that's why I told you should take current, not the R. Position vector நம்ம எடுக்கல. We are not taking R. We are considering only current vector we are considering. So K times IDL sin theta upon R square. Yes, this is the exact expression. Okay, this expression is called the expression for Biot-Savart law. Okay, simple. Now, what is K? K can be expressed as mu naught upon 4 pi. So this is the relation for K. இங்க epsilon naught வராது, mu naught வரும். Mu naught is nothing but permeability of free space. So mu naught is called permeability. Okay, pi வந்து உங்களுக்கு தெரிஞ்சது தான் 3.14 or 22/7. So this is the constant. So finally, what will be the expression? You get dB is equal to mu naught upon 4 pi times I into dl into sin theta upon r square. So this is the final expression. Okay, so this expression is very important to us. Mu naught values வந்து நம்ம question solve பண்ணும்போது mu naught we will substitute, we will take the value for mu naught as 4 pi into 10 to the power minus 7. The units are Tesla, meter upon ampere. So that is the unit of mu naught. So mu naught value is always 4 pi times 10 power minus 7. So we will be substituting that while solving questions. So this is the second concept of Biot-Savart law, so which we have covered today. Next, going to the third concept. Okay. Next, we are seeing magnetic field due to a straight current carrying conductor. So அடுத்தது நம்ம இதான் பார்க்க போறோம். What is a magnetic field due to a straight current carrying conductor? Okay.
ஓகே சார்.
Yeah. So இங்க வந்து
சார்
யா சொல்லுங்க
சார் மியூ நாட் உடைய வேல்யூ மட்டும் கொஞ்சம் காட்டுங்க சார்.
எஸ் மியூ நாட் வேல்யூ வந்து ஸோ இதுதான் ஸ்க்ரோல் பண்ணிருக்கேன் பாருங்க 4 pi into 10 power minus 7. வேணா இன்னும் கொஞ்சம் ஸ்க்ரோல் பண்றேன். யூ கேன் மேக் அ நோட் ஆஃப் த ஸ்டெப்ஸ்.
சார் எடுத்துட்டேங்க.
ஓகே சரி. அடுத்தது வந்து மேக்னெட்டிக் ஃபீல்ட் டியூ டு ஸ்ட்ரெயிட் கரண்ட் கேரிங் கண்டக்டர். ஸோ இப்போ இதுக்கு முன்னாடி நம்ம பார்த்த கண்டக்டர் பார்த்தீங்கன்னா அது வந்து இட்ஸ் நாட் ஸ்ட்ரெயிட், ஒரு கர்வ்ல இருந்திருக்கு. ஸோ இது வந்து ஒரு ரேண்டம் கண்டக்டர் தான் நம்ம கன்சிடர் பண்ணியிருக்கோம். ஸோ இப்போ வந்து நம்ம கண்டிஷன்ஸ் ஆர் டிஃப்ரெண்ட், அவர் கண்டிஷன்ஸ் ஹவ் சேஞ்ச்ட். இப்போ நம்ம ஒரு ஸ்ட்ரெயிட் கரண்ட் கேரிங் கண்டக்டர் கன்சிடர் பண்ணுறோம். ஸோ வி ஆர் கன்சிடரிங் a straight current carrying conductor. So இதுக்கு வந்து சில basic intro கொடுத்துறேன். So this is basically magnetic field at a point. So we are investigating. So we would like to investigate magnetic field at a point at perpendicular distance, at a perpendicular distance, say A, perpendicular distance A from a straight conductor carrying current. Straight conductor carrying current I. Okay. So here, inge pathina, what are the important parameters? The distance is A from the straight current carrying conductor, and the current is typically I. So then, what is the expression for magnetic field? We will go directly for the expression. It is given by B is equal to mu naught into I upon 4 pi A into sine phi 1 plus sine phi 2. So this is our expression for magnetic field due to a straight current carrying conductor. So
சார்
yeah,
சார் ஃபைவ்
சொல்லுங்க.
எது சார் ரெப்ரசென்ட் பண்ணுது?
Phi வந்து angle represent பண்ணுது. So I will show you the figure. So if I take a straight current carrying conductor, so imagine this is our straight current carrying conductor. இதை வந்து நான் mark பண்ணிக்கிறேன். So let's mark this as XY, and I'm telling that I is the current flowing through it. சரிங்களா? இப்போ as per the definition or what I have given basically, so we are finding the magnetic field at a point with a perpendicular distance. Appo I am choosing a point which is perpendicular ipdi. So inga or point nama choose pandrom, and the point வந்து நம்ம P name பண்ணிக்கலாம். So then what is the magnetic field at this point if this distance is going to be A? So this distance from that straight current carrying conductor is going to be A. So then we are finding what is the magnetic field associated at this point. So அப்போ நம்ம வந்து இந்த ஃபிகரை வந்து கம்ப்ளீட் பண்றதுக்கு என்ன பண்ணுவோம்? We are considering entire straight conductor. So the angles that are made with respect to these parts. So we will take the angles as phi 1 and phi 2. So in the angle எடுத்துக்கலாம். So this is phi 1. Same way this angle is going to be phi 2. Okay. So a right angle triangle form பண்ணது நம்ம trigonometry apply பண்ணோம்னா நமக்கு sin relation வரும். So the relation which basically links the opposite side and your hypotenuse. So on the XP or relationships வந்து we are expressing in terms of sin thetas. அவ்வளவுதான். Okay. So we will get the final answer as B is equal to mu naught I upon 4 pi A times sin phi 1 plus sin phi 2. Okay. இதுக்கு வந்து ஒரு பெரிய டெரிவேஷனே இருக்கு. இப்போ நமக்கு டைம் கன்ஸ்ட்ரெயின் இருக்கிறதுனால we are not entering the full derivation. So I'll give you the direct relationship with the figure. நம்ம question solve பண்ணும்போது obviously உங்களுக்கு clear ஆயிடும். So it's not a big deal. So just the formulas aspect we are seeing today. Okay. Yeah, moving on to the next one. So I hope this is clear. Magnetic field due to a straight current carrying conductor. Okay, so we'll move to the next part. The fourth part. So இப்போ இங்கே சில கண்டிஷன்ஸ் கூட இருக்கு இந்த previous இதுக்கு வந்து. Now if the angles are going to increase, so இங்கே ஒரு கண்டிஷன் இருக்கு. If phi 1 and phi 2 are equal to pi by 2. Pi by 2 na நம்ம radian mode la பாத்தீங்கன்னா it is you convert from radian to degree, you will understand that this is 90. So if they become 90 degrees, then the magnetic field is going to be B is equal to mu naught I upon 2 pi A. These are the conditions. These are the conditions apply. So that is when both the angles phi 1 and phi 2 is equal to 90. In that case, you will get mu naught I upon 2 pi A. சரிங்களா? So 4 pi A வந்து 2 pi A ஆயிடும். எப்படின்னு புரியுதுங்களா? So sin 90 வந்து 1 தானே. So 1 plus 1 is 2. 2 and 2, 4 will get cancelled. You will get 2 pi in the process. So these are the formulas. These are the modified versions with respect to the angles. So angles மாறும்போது formula கூட appropriate மாறும். 30 degrees கொடுத்தாங்கன்னா 30 sin 30 apply பண்ணுவீங்க. 45 degrees கொடுத்தாங்கன்னா sin 45 apply பண்ணுவீங்க. So அந்த மாதிரி this is based on the angles. Okay, for 90 degrees it is going to be maximum. So that is what we try to understand. Sorry, so now we are moving on. Next we have magnetic field. So next we are seeing what is the magnetic field of a circular current carrying loop. Of a circular current carrying loop. So what is a magnetic field? அது நம்ம பார்க்கலாம். A loop of radius. Okay, I'll give you the values also. Loop having radius A carrying current I. Having radius A. Okay, anyways, current already I have mentioned. So this is the current I. So what is the magnetic field? Okay. So இதுக்கு வந்து ரெண்டு aspect இருக்கு. The magnetic field at the center of the loop it is given by B is equal to mu naught I upon 2A. So this is a formula for magnetic field at a center of a circular loop. Center இருந்துச்சுன்னா நம்ம இது யூஸ் பண்ணுவோம். If you want to find the magnetic field at the center, you will use this formula. Same thing if it is at an axial point located at a distance r from the center. Axial point அப்படின்னா சென்டர்ல இருந்து கொஞ்சம் distance. It is from the center itself. So that is given by B is equal to mu naught I A square upon 2 times R square plus A square the whole to the power 3 by 2. So this formula we will use when it is at an axis, when it is at an axial point. So these are the formulas for a current carrying circular loop. எடுத்துக்கிட்டோம்னா these are the magnetic fields at the center and at the axis. ஓகேங்களா? That's it. So இந்த ஒரு relations வந்து நம்ம யூஸ் பண்ணுவோம். So when you see a loop, so this is how the loop looks. And this is the center of the loop. Let me mark it as O. So at O, you will use first formula. Same thing at a distance of R from O. Say at this point, you will mark this point as P. So OP வந்து, so at point P வந்து you will use the second formula. அவ்வளவுதான். That is the only relationships. Okay. So like that you will apply the formulas due to a current carrying circular loop. So we will show the direction of current also in this loop. That's it.
Okay, sir.
Okay. So then we are moving on to the fifth concept. Okay. அடுத்தது வந்து we have something called as the Ampere's circuital law. ஏன்னா Ampere's law அப்படின்னு சொல்லுவோம். We'll see what is that. Ampere's circuital law. So according to this law, I'll give you the statement. The line integral of magnetic field, the line integral of magnetic field B bar around any closed path is equal to mu naught times the total current mu naught times the total current I passing through it. Okay, passing through it. So according to Ampere's circuit law, என்ன சொல்றாங்க அப்படின்னா line integral. Line integral you are only applying this for a closed loop. ஒரு closed loop இருந்துச்சு அப்படின்னா so அந்த closed loopல what is the magnetic field around that path, அந்த pathல இருந்தா நம்ம பார்க்குறோம். So if you find out magnetic field at that path, not center of that path, at that path itself we are finding. So that is the difference between this and this. Previous conceptல வந்து circular loop தான் நம்ம இது இங்கேயும் எடுத்திருந்தோம், but we are investigating magnetic field at the center of the circular loop or at a distance of r from the loop. ஆனா இங்க வந்து நம்ம we are finding magnetic field on that path itself. That is the difference. Okay, so on the path itself we find. So on the path, if you want to find the magnetic field, you will say, you will apply an integration concept, closed integral of B dot dl is equal to mu naught times I passing. I is basically the current passing through that loop. So obviously all loops are closed. Yes. So therefore, this integral itself represents closed path. So you basically represent this integral for closed path. So எல்லாமே closed path தான் obvious. So அதனால this whole entire integral on the left hand side, that is the left hand term itself, is representing the closed path. So the magnetic field on that closed path is equal to mu naught, that is permeability, times the current passing through it. Now if there are n loops, okay, so if there are n loops, then what will you say? You can further say the magnetic field is going to be mu naught ni times. So it becomes mu naught ni if there is going to be n number of turns or n number of loops அப்படின்னு சொல்லுவோம். So அது நம்ம solenoid அப்படின்னு சொல்லுவோம். So that also we are going to see. That is the next concept that we are going to see. Okay, so this is Ampere's circuital law. So what does this say? If you take a closed path, the line integral of that closed path, the magnetic field associated with that is going to be mu naught times the current passing through it. So this is the expression. Same way, if there are n loops, you can express it in terms of mu naught ni. Just a basic aspect. Okay, so next we are moving on to the next concept. Magnetic field of a straight solenoid, we will see. So magnetic field of a straight solenoid. So solenoid வந்து பாத்தீங்கன்னா it is nothing but a long insulated wire made of copper. Okay, that is wound in a shape of a spring. So spring மாதிரி நீங்க அதை ரோல் பண்ணீங்க அப்படின்னா நம்ம அதை தான் நம்ம solenoid அப்படின்னு சொல்லுவோம். Okay, helix shapeல. So helix shapeல வந்து you just roll it. So the result of that is called a solenoid. Yeah.
Solenoid என்ன சார்?
Solenoid வந்து it's an insulated wire. It's a long insulated wire made of copper. சரிங்களா? So you are going to wind it around any object. For example, ஒரு metal ஒரு iron bar எடுத்துக்கோங்க. You take an iron bar and you are going to wind it around it. நம்ம எதுக்கு wind பண்ணணும் ஒரு iron bar? So the question is, the reason is you wanted to magnetize it. So you want to introduce a magnetic property into it. That is the reason you go for winding. Okay, so this solenoid is nothing but it's a winding of insulated copper wire over a metal object, over a metallic core, usually soft metallic core நம்ம எடுத்துக்குவோம். So அந்த ஒரு செட்டப்பை தான் நம்ம solenoid அப்படின்னு கூப்பிடுறோம். So what does the solenoid do? The solenoid will basically provide a magnetic property to the object that is being wound around. So நீங்க அது எதை outside which you are winding it, so நீங்க on which object you are winding it, it would basically give a magnetic property. Now it is not any object, random object, no. Plastic objects எல்லாம் போடக்கூடாது. Only metallic objects are accepted. Okay. So around any metallic objects, if you are going to wind it, so you are constructing so called an electromagnet. So electromagnet அப்படின்னு பார்த்தீங்கன்னா, when you switch on the current, it will show magnetic property. Current off பண்ணிட்டீங்கன்னா, there is no magnetic property involved, or there is no magnetic property associated with it. சரிங்களா? ஸோ நார்மலாக ஒரு அயன் ராட் எடுத்துக்கிட்டோம்னா அது வந்து அட்ராக்ட் பண்ணாது இன்னொரு அயன் ராடை, இல்லைனா இட் வில் நாட் அட்ராக்ட் எனி பின்ஸ், இல்லையா? பட் இஃப் யூ wind insulated copper wire around the iron rod and connected to a battery along with a cell, along with a plug key, what happens is it will show magnetic property which is temporary. Temporary na, until current passes through it, it will show. நீங்க current circuit off பண்ணிட்டீங்கன்னா it will not show magnetic property.
Not so, permanent, sir.
Yes, it is not permanent. Correct. Bar magnet எல்லாம் பார்த்தீங்கன்னா permanent. Bar magnet, horseshoe magnet இதெல்லாமே permanent magnetic field. And a solenoid பார்த்தீங்கன்னா it is something which is temporary magnetic field. So only until current passes, magnetic field காமிக்கும். Once current is off, it is as good as a normal object, non-magnetic object. Okay, it will not show any magnetic property. So that is the reason solenoids are classic examples of electromagnetic magnets. So இதை வந்து நம்ம ரியல் லைஃப் அப்ளிகேஷன்ஸ்ல பார்த்தீங்கன்னா நம்ம நிறைய இடத்துல யூஸ் பண்றோம். solenoids வந்து we are using in so many areas. One example is basically our fan. In our fan also you have solenoid kind of a setup. அது வந்து டாராய்டுன்னு சொல்லுவோம். அதே சாலினாய்டு வந்து ஸ்ட்ரெயிட்டாக இருந்துச்சுன்னா சாலினாய்டு, அது வந்து டோனட் ஷேப்பில் நம்ம வந்து அதை வளைச்சோம் அப்படின்னா டாராய்டு அப்படின்னு சொல்லுவோம். ஸோ தட் இஸ் யூஸ்ட் இன் த சீலிங் ஃபேன்ஸ். ஓகே, சேம் வே மோட்டர்ஸில் யூஸ் பண்ணுறோம். வி ஆர் யூசிங் ஈவன் இன் எலக்ட்ரிக் பெல்ஸ். ஸ்கூல்ஸில் பார்த்தீங்கன்னா அந்த எலக்ட்ரிக் பெல்ஸ் இருக்கு இல்லையா, தேர் ஆல்சோ த solenoids are being used. So like this, there are different applications for solenoid. Okay, so we will see what is this. So solenoid is nothing but, so here I'll give you the definition. So a solenoid is a long insulated wire long insulated wire wound in the shape of a spring, இல்லைனா ஹெலிக்ஸ்ன்னு சொல்லலாம். ஓகே, in the form of a helix. So the length of the solenoid, is very large compared to its diameter. This is something which is important to know. So its length is very large compared to its diameter. So solenoid எப்படி represent பண்ணுவோம்? So I take a metallic core. So this is the metallic core. So I take now a copper wire and I'm going to wind the copper wire. So it will look like this. So what we have shown here is basically a solenoid. Okay, this is a solenoid setup. So let me mark the points. This point is A, this point is B. So the length is L, okay, and diameter only we can give it as D. So this is the diameter. Of the solenoid. சரிங்களா? So this is how it looks in real life. Okay, so the length of the solenoid is very large compared to its diameter. So this is something that you should basically know. Okay, number of turns வந்து நம்ம n represent பண்ணுவோம், where the number of turns okay, where the number of turns are n, okay, small n per unit length. So we can express it like that. So therefore, magnetic field. Now we will understand what is a magnetic field. Now the solenoid part is clear. So the magnetic field associated with the solenoid is given by B is equal to mu naught n into I. This is the formula. So using Ampere's rule itself, you can find out that. Okay, Ampere's law பிரகாரம் வந்து உங்களுக்கு தெரியும், for any closed figure, the magnetic field associated with that closed path is basically mu naught times I. So இங்கேயும் closed path தான், but you have n number of turns, அதனால mu naught ni. சரிங்களா? So this is a point at point inside the solenoid. So this is magnetic field associated inside the solenoid. So solenoid kulla vandu we express like this. Same way outside. Okay, at the end of the solenoid, instead of saying outside, we'll put it like this. At the end of the solenoid, what happens? What is a magnetic field? B is equal to mu naught ni by 2. Why by 2? Because it has got two ends. So we divide by 2 and we express it. So this is the magnetic field at either end of the solenoid. At either end of the solenoid, you can find out magnetic field as this. Okay, simple. So this is the formulas that you should know. Okay.
Okay, sir.
So this is all about solenoid. I hope solenoid concept is now clear. So over page, let me show you. So this is all the magnetic field associated with a solenoid which is straight. So we express it like this. So that's it. So shall we go to the next part? Is that clear? I hope this part is clear.
Yes, sir.
Okay. Next, the seventh one. அடுத்தது நம்ம பார்க்க போறது வந்து force. What is the force on a moving charge placed in magnetic field? Okay. Next, we will see what is the force experienced by a moving charge placed in magnetic fields. So in the force one, so when you have a charge moving with a velocity v and at an angle theta in the magnetic field B, so அப்போ அதோட force என்ன அப்படிங்கறத நம்ம வந்து investigate பண்ண போறோம். So here we wish to find out what is the force, that is a charge Q. Let's say Q is usually the symbol we use. So a charge Q moving with a velocity v bar at an angle, so say at an angle theta, with magnetic field d bar. Okay, so when you have a charge that is moving, then what is the force experienced by the charge? So அப்போ force experienced will have two different aspects. ஏன்னா ஒரு சார்ஜ் அப்படிங்கிறதுனால உங்களுக்கு தெரியும் சார்ஜ் வந்து will have an electric force component also. Okay, because you are placing in magnetic field, even magnetic force is also applicable to it. So the net force is the summation of force due to electric field plus force due to magnetic field. ரெண்டுமே இருக்கும். So these are the two forces that are involved. So electric field ஓட force formula என்னது? ஏற்கனவே நீங்க electric field and chargesல வந்து நம்ம பார்த்தது தான். F is equal to, you will apply the formula Q into E. ஞாபகம் இருக்குங்களா? So you will apply this formula for force due to electric field plus force due to magnetic field is given by again we express this also in terms of Q. Now we are expressing as a cross product of V times B. V bar cross B bar. So we express in terms of the cross product. Okay. So this is how we are going to express. So in the force அதான் நம்ம வந்து Lorentz force அப்படின்னு சொல்றோம். This net force is called Lorentz force. So it's given by Q into E bar. Okay, so I'm taking Q as common. Now you can see it's there on both the terms. So within brackets you can say bar plus V bar cross B bar. So this is the notation for Lorentz force. Now what is V bar cross B bar? Now ஏற்கனவே சொல்லி கொடுத்தது தான். Cross product வந்து நீங்க you can express in terms of the angle theta. So what is the expression? இப்போதான் நம்ம பார்த்தோம் A bar cross B bar எப்படி எழுதுவோம்? So how do we express? Yes? Could you try? Yeah, so A bar cross B bar, how do we express? It is AB sin theta. The same way.
Yes, sir.
Vector notation.
V dot B sin theta.
Yes, VB into sin theta. Okay, so we can express like this. So you further go and express it. So final expression would become Q times electric field vector plus VB, that is V bar B bar into sin theta. Simple. So this is the Lorentz force formula. So this is the expression for Lorentz force. Okay, that is whenever you have a charge moving in magnetic field, what is the force experienced by the charge if it is making an angle theta with magnetic field? Now this is the expression, final expression. Okay, so moving on to the next part. So we'll see what is next. ஸோ இதுக்கப்புறம் நமக்கு ஃப்ளெமிங்ஸ் ரூல்ஸ் அப்படின்னு சொல்லி இருக்கு. ஃப்ளெமிங்ஸ் லெஃப்ட் ஹேண்ட் ரூல், ஃப்ளெமிங்ஸ் ரைட் ஹேண்ட் ரூல். ஸோ இது நீங்கள் 10th கூட படிச்சிருக்கலாம். ஸோ டு யூ ஹேவ் எனி ஐடியா அபவுட் ஃப்ளெமிங்ஸ் ரூல்ஸ்? ஃப்ளெமிங்ஸ் லெஃப்ட் ஹேண்ட் ரூல். ஸோ வி ஆர் கோயிங் டு சி வாட் இஸ் த ஃப்ளெமிங்ஸ் லெஃப்ட் ஹேண்ட் ரூல். ரொம்ப ஈஸி தான். ஸோ when you stretch the thumb, your index finger and the middle finger of your left hand such that they are mutually perpendicular to each other, thumb will indicate the direction of force on the conductor, the index finger will indicate the direction of magnetic field, and middle finger will indicate the direction of current. Avladha. So this is Fleming's left hand rule. Okay, so I will just give you the basic definition. So when we stretch the thumb, index finger and middle finger such that they are mutually perpendicular to each other. Thumb indicates, so thumb indicates the direction of magnetic field, not direction, that is force on the conductor. Sorry, direction one is index finger. Okay, so thumb indicates force. So force on the conductor. Same way, index finger indicates direction of magnetic field. And lastly, middle finger indicates the direction of electric current or the direction of current. That's it. சரிங்களா? So this is all about Fleming's left hand rule. So இதை வந்து நம்ம represent பண்ணுவோம் using a simple notation. Okay. So we use the notation like this. So these are the axes. So this is your thumb. Okay. And this is index finger. And this is the middle finger. So, so what does the thumb indicate? It indicates force. The index finger indicates magnetic field. And middle finger indicates current. அவ்வளவுதான். So this is called Fleming's left hand rule. So Fleming's left hand rule நம்ம எதுக்கெல்லாம் யூஸ் பண்ணுவோம்? We are using Fleming's rule, left hand rule, particularly for conductors which carry current in them. So in conductors where current is being passed, you can apply this rule and you can find out what is the force. Either you can find force, you can also find the direction of magnetic field. So in the directions மட்டும் தான் நம்ம கண்டுபிடிக்க முடியும். You cannot find out the value of force. That is not possible here. Here you can find out in which direction the force is acting. Simple. Same way, in which direction the magnetic field is also going to act. That also you can find out. Provided you know the direction of current. Any two things you know, you can find out the third one using this rule. Okay, so that's the Fleming's left hand rule. That is the scope of this rule. So next we have, adhe mari, you have something called as Fleming's right. I mean, before we go to that Fleming's right hand rule, we will see one more. It is also called as right hand thumb rule. Okay, so adu kuda nama paathirulam. So what is right hand thumb rule? தெரியுமா?
சரி, வெக்டர் ப்ராக்கெட்ல யூஸ் பண்ணுவாங்க.
ஆமா. So right hand thumb rule. So according to right hand thumb rule, if you are holding a current carrying conductor using your right hand, thumb will indicate the direction of current. The remaining four fingers which coil around will indicate magnetic field. Avladha. So this is the right hand thumb rule. Okay. So I'll just write the definition. When we hold a current carrying conductor, just imagining to hold, we don't really do it. When we hold a current carrying conductor with our right hand, so the thumb indicates direction of current while the coiling of four fingers indicate the magnetic field. So this is your this is what the right hand thumb rule tells. So if this is a direction of current, so அதாவது உங்க thumb வந்து இந்த directionல point பண்ணுது. So this is the direction of current, so we will say this is thumb. Then magnetic field will be like this. So this is coiling of four fingers. So thumb indicates the direction of current, while coiling of four fingers indicate direction of magnetic field. That's it. Okay, so this is right hand thumb rule. சரிங்களா? Same way,
ஓகே சார்.
yeah, same way we have Fleming's left hand rule also. That is opposite of right hand rule. Okay, so we have Fleming's right hand rule. Left hand rule we have seen. Now we are going to see Fleming's right hand rule. Same way we are going to explain. So when we stretch the thumb, index finger and middle finger, same way, such that they are mutually perpendicular to each other, the thumb indicates the direction of force, index finger indicates magnetic field, while middle finger indicates இங்க தான் ஒரு difference, induced current. Instead of current we say induced current. So it indicates induced current. அவ்வளவுதான். So induced current na the current which is not, you are not providing, circuit is generating, so that is the induced current. சரிங்களா? So current has been produced rather. Okay, so generators எல்லாம் பாத்தீங்கன்னா we are using generator systems nowadays in buildings. So when there is a power cut, obviously generator is going to be a backup, so it provides the current for backup. So அது வந்து எப்படி ப்ரொடியூஸ் பண்ணுது? Obviously it is because of Fleming's right hand rule ஒரு application தான் அது. So according to Fleming's right hand rule, you know that when there is magnetic field, when there is rapid change in magnetic field with respect to the force being applied, so then you can see that there is a current which is being produced or which is being induced. So அதுதான், so that is the reason you can see that there is a current that is being produced. We are going to see all this in detail. It is just a basic idea, so I'm just giving you. So here Fleming's right hand rule, again we represent the diagram also for this. For this the diagram would look like this. So this is the thumb.
சார்
சொல்லுங்க.
சார் லெஃப்ட் ஹேண்ட் ரூல் வந்து ரைட் சைடுல இருக்குதே சார்.
புரியல, திரும்பி சொல்லுங்க.
சார் இப்போ இல்ல சார், ஃப்ளெமிங் உடைய ரைட் ஹேண்ட் ரூல் வந்து லெஃப்ட் ஹேண்ட் சைடுல இண்டிகேட் பண்றாங்க, லெஃப்ட் ஹேண்ட் ரூல் வந்து ரைட் சைடுல இண்டிகேட் பண்றாங்க சார்.
ஆமா,
அதுக்கு ஏன் சார் அப்படி பண்றாங்க?
ஆமா, நீங்க கை ஸ்ட்ரெச் பண்ணி பாருங்க, உங்களுக்கே புரியும். ஸோ ரைட், when you have your right hand, நீங்க வந்து தம்பையும் இண்டெக்ஸ் ஃபிங்கரும் அப்புறம் மிடில் ஃபிங்கரை ஸ்ட்ரெச் பண்ணி you place it. How does it look? It is oriented towards the left தானே?
எஸ் சார்.
That is the reason we are representing like this. இதுல என்ன இருக்கு? Okay, it's purely based on the representation. Okay, so thumb indicates force, index finger is going to indicate magnetic field, அப்புறம் middle finger is going to indicate the induced current. அவ்வளவுதான், simple, quite simple. So this is all about Fleming's right hand rule. So we have covered all the rules. So we saw right hand rule, we saw Fleming's left hand rule, we also saw, I mean, right hand thumb rule. See, this also we have seen. So the three important rules governing magnetic field is covered. So this also we have finished. Okay. So now we are moving on to the next aspect.
சார் கொஞ்சம் இதை காட்டுங்க சார், காப்பி பண்ணிக்கிறேன்.
Yes, yes, yes. Copy பண்ணிட்டு சொல்லுங்க. I'll wait for you.
சார் காப்பி பண்ணிட்டேன் சார்.
Okay, copy பண்ணிட்டீங்களா? Sure. Go to the next part. So next பார்த்தீங்கன்னா we are going to see what is the relation between electric field and electric potential. So that is necessary for us. So அது வந்து நம்ம ஏற்கனவே பார்த்தது தான் இந்த first chapter, but still we can see the relationship between. So what is the motion of a charge placed inside an electric field? So motion of a charge placed inside electric field. So இதுதான் நம்ம பார்க்க போறோம். So when you have a charge which is placed in electric field, the electric field experienced by that charge is given by the relation. So E is equal to, where V is electric potential and D is nothing but the distance of separation from that charge. Okay, so here we apply the concept of the plates. Okay, so I'll give you the basic definition here. If a potential difference or if a potential V is applied between two parallel plates separated by a distance d, small d, then electric field associated between the plates is, so electric field associated between the plates is given by the expression. So அதுதான் இது. E is equal to V upon D, where E is electric field, V is nothing but the potential, D is the distance of separation between both the plates. So இதை வந்து நம்ம diagrammatic-ஆ இப்படி represent பண்ணலாம். So when you take two different plates, so இது வந்து ரெண்டு plates நம்ம எடுத்திருக்கோம். So when you are applying potential between these plates, so how do you apply potential? You connect these plates to a cell along with a plug key. இந்த மாதிரி connect பண்ணீங்க அப்படின்னா you can apply potential between the plates. Now the distance bit of separation between the plates is D. So இந்த மாதிரி நம்ம எடுத்துக்கிட்டோம் அப்படின்னா then electric field is obviously set up between the plates that is given by E. So E is the electric field. So that is given by the relationship E is equal to V upon D. So the force experienced, so the force experienced by a charge, okay, the force experienced by a charge between the plates is given by, so we are going to represent the force, so F is equal to, where Q is the charge and E is the electric field. புரியுதுங்களா? So we are expressing it like this. F is equal to Q into E.
Manish,
So
can
that is
we
going to
close
be
in
the
another 5 minutes?
force that it is going to experience.
Manish, can we close in another 5 minutes?
Yes, uncle, we'll
Okay.
wind up in 5
கொஞ்சம்
minutes.
பார்த்து.
Okay. So F is equal to Q into E, where F is the force, Q is the charge, and E is the electric field associated between the plates. ஏன்னா நம்ம வந்து potential apply பண்றதுனால there is an electric field also being associated. ஏன்னா நம்ம current electricityல வந்து ஏற்கனவே பார்த்தோம். I have taught you. You can refer that module as well. So அங்க there is electric field also coming into picture. So இப்போ நம்ம முன்னாடி இருக்க ஃபார்முலா வந்து இங்க சப்ஸ்டிட்யூட் பண்ணலாம். So if substitute that formula, what happens? You get F is equal to Q V upon D. So this is an important relation which we use for solving numericals, quite useful. So we can use this relation. This is one relation. One more relation, நம்ம நியூட்டன்ஸ் லா கூட யூஸ் பண்ணலாம். இப்போ நியூட்டன்ஸ் லா பாத்தீங்கன்னா, what does Newton's second law tell you? According
F
to
is equals to M into A.
very good. So from second law of Newton's, we know that F is equal to M into A, where M is mass, A is acceleration. So இங்க நம்ம சார்ஜை பத்தி பேசும்போது, obviously we are talking about the electrons, or it might be protons, it can be anything. So they are all having some mass. Yes, of course they have a mass. So we can substitute in the place of F, M into A. So மேல M into A substitute பண்ணுங்க. So what happens? I will get relation as M into A is equal to Q into E. Okay, you will get relation like this. So you can also find out what is the acceleration of the particles placed between the plates having electric field E and potential V. So A is equal to,
divided by M.
yes, you will get QE upon M. So this is the acceleration associated with them. Okay, so like this we can find out the acceleration. So in the mari we need to understand, you know, the formulas. நமக்கு என்ன கொடுத்திருக்கு, given data first analyze பண்ணுங்க. என்ன கொடுத்திருக்காங்களோ அது பிரகாரம் you can apply whatever formula you want. Suppose in the question they have given you say acceleration, and they have given you the electric field. So and they are asking you what is the charge. Obviously you would use this third formula. Okay, so based on the given data you wisely choose which formula would be a perfect match or a perfect fit. So அது பேஸ் பண்ணி நீங்க இதை யூஸ் பண்ணிக்கலாம். So 3 formulas இங்க இருக்கு. So you can use any one of them to find out any one of the parameters.
Okay, sir.
Okay, same. So இன்னொரு கான்செப்ட் இருக்கு, that is little bigger. So because there is a time constraint, so we will wind up here. Okay, for today. That will take 10 minutes for me, but we don't have 10 minutes. So yeah, that we will see in the next lecture. சரிங்களா?
Okay, என்னோட லேப்டாப் இட்ஸ் டவுன். ஸோ ஐ ஹேவ் எ கிளாஸ் அட் 9:10. அதனால தான் வேற ஒன்று.
அப்படிங்களா? ஓகே ஓகே,
வேற
ஒன்றும்
ஒன்று
பிரச்சனை.
ஏதோ ஒர்க் ஆக மாட்டேன் என்னோட லேப்டாப்.
அப்படிங்களா? சரி சரி, ஓகே.
தேங்க்யூ.
யா வெல்கம்.